How in the world can land-based melting ice, like on a glacier, contribute to sea level rise, but sea ice, floating sea ice, doesn't? When it sticks up above the water, why doesn't it melt and raise the water level? We'll have to figure this out. Hey, Rocky, I got a question. Can you help me with something? Why does melting sea ice not contribute to sea level rise like land-based ice does? All right, go back to eat. Creek. Why does melting sea ice not contribute to sea level rise like land-based ice does? Can you help me with that? Okay, well, never mind. Go back to eat. Well, since Rocky the horse and Creek the goat were not much help explaining why melting floating sea ice does not contribute to sea level rise like melting land-based glacier ice, I decided to help understand it with an experiment, and that's what this video is about. I had two medicine cups here, measuring cups. You measure out 30 milliliters of whatever for cough syrup, whatever it might be. I filled them right to the brim and froze them. This one is frozen still. I haven't thawed it out. This one, I took I had another one, and it was in this empty cup here. I took that frozen ice out, put it in this beaker here. It's a 50 milliliter glass beaker. And you'll notice that the ice from that frozen water cup or medicine cup is floating just above the water level here, and it's right to the brim. So as this melts, why wouldn't it overflow? Well, the reason is, since it's less dense, as it melts and becomes water, it becomes more dense, it simply stays exactly the same. Really no difference, because the amount of water that's going to be in here is already here. And so that's why it looks like this, and that's why as it melts, it will not raise the level. And we'll do this on a time lapse just to prove it. This one here is right to the brim, but still solid ice. As it melts, it should drop down slightly from the rim there, as it loses about 10% of that volume. So remember, ice is only 90% the density of water, which is mass per unit volume. So we're going to set this up for a time lapse and see if we can track this. Okay, here's our time lapse. Watch this ice melt. It's melting quickly, but the level stays the same in the beaker. Let's go back here. If you're looking at this one starts out full of ice, the level drops. As the ice melts, it becomes more dense when it turns into water. Therefore, the volume decreases, and that's why the level drops in that cup. So this one stayed the same. As the ice melted, didn't overflow. Here the level dropped. As the ice melted, it lost volume, and that's why it looks like this. Both of these glasses are filled with ice and water to about right here. And I'll put a little mark on there. This is simulating a land-based glacier that's being held back by sea ice. That's exactly what you got going on in Antarctica and some other places too, like possibly Greenland. But what we're going to do is just put on time lapse, let them melt, and let's see what happens. Okay, we got ice in this glass. We got a mark here where the water level is. Got the same amount of ice here. Mark where the water level is. This is simulating some land-based ice like a glacier. We'll speed this up in a time lapse, and what you'll see is this ice here, even though it's higher than the water level, as it melts will not increase the water level. This ice here, it's basically the same as that sea level ice. It's floating, but as it melts, it doesn't increase the water level. But what's happening is this ice here that's simulating the glacier is melting and moving towards this way. So we'll go ahead and start this and watch this water level here come up as this ice melts. See it? It's coming up there. This water level's staying the same. You can see it over here. That one's coming up as this land-based ice, this glacier simulating ice here, will fill up this glass right to the brim and it'll start to overflow. Okay, this is a time lapse as I finish letting all the ice melt. It'll be completely melted at the end of this, and you'll see all we're doing here is overflowing the glass on the right as that so-called land-based ice or glacier ice melts and adds new water to that glass. The one on the left stays the same. Thanks for watching. I hope you enjoyed the video. If you did, please like it, subscribe if you're not a subscriber already, and check out our other links. We'd really appreciate it. And thanks again for watching.